Alright guys, today we're going to look at some applications of exponents, particularly with exponential growth and decay. So the first thing we're going to look at is a very basic equation that just kind of talks about the different components we'll need to have in order to determine exponential growth and decay. And that E is pretty faint there, sorry. So the first thing we have, that y sub t, that is your initial, that is your amount after the time t. So whatever time you have as your t variable, it's the amount after that time. The y with a little sub-zero, that y naught, that is your initial amount, so how much you start with. R is your rate, and rate is just written as a decimal. And then t is your time. Now time can be in days, hours, minutes, seconds, whatever you want it to be in. However, you need to keep that consistent for the entire question. So if you use hours here, then your amount needs to be, your amount after time needs to be after hours. Okay, so just keep your time rate consistent. So in order to do this, what we're going to do is look at one of the questions on the homework, particularly one about half-life. Now, there's a lot of different applications about exponential growth and decay, but the most important thing about all of them is that the first thing you need to do, no matter what, is to find your rate. So if the rate is not given to you, you need to solve for the rate before you do anything else. And one thing to keep in mind here, the half-life is not actually your rate. Okay, so we're going to look at this archaeologist question, and it tells us that it has a half-life of 15 hours. So we're going to use that information to solve for our rate. So if the half-life is 15 hours, that means after 15 hours, no matter how much I start with, I will have half of that amount at the end. So I can pick any numbers to start with for that question. In particular, let's say I have a starting of 2 of whatever my sample size is. Then, after my half-life, I'll be left with 1. That half-life is 15 hours. I don't know R, so that's going to be my X. So after 15 hours, I would go from 2 to 1. So now I just need to solve for X. And the way I do that first is I get E by itself. So I'm going to divide by 2. And then I'm going to rewrite this as a natural log. So that's going to be the natural log of 0.5. And then to solve for X, I just have to divide by 15. And then I would type this in my calculator. And what you guys will notice is you're actually going to get a negative number for your rate. And that's okay. It actually makes sense for our question, because we're talking about half-life, which means that this subject is decaying. And if it's decaying, our rate has to be negative. So the rate that I have is a negative 0.0462. And I'm going to go to at least 4 decimals, 4 places past the decimal, because this is a percent. And the more rounded this is, the more off your numbers are going to be. So once I have found my rate, I'm going to use that rate to solve for the missing parts of this question. So in this case, the rate that I have here, that negative 0.0462, I'm going to use that in my equation. So what my equation says is just to rewrite it. So my question tells me how many hours will it take for 40% of the substance to remain. So what I'm looking for is my time. That's going to be my missing variable. So the way I'll do this is 40%, again, I can pick any numbers I want as long as my initial amount is, as long as my amount after time is 40% of my initial amount. So the easiest numbers to pick are going to be 40 and 100. I know my rate now, I'm going to use that number. And then my X this time is time. So it's going to solve this question for time, and I'll solve it the same way. I'll divide. I'll rewrite it as a natural log. And then I'll solve for X by dividing by that negative 0.0462, and I'll get my answer, which is about 19.8 hours. Now, exponential growth and decay, they're each going to be a little bit of a different question, but the biggest thing to keep in mind in all of these is the first thing I need to do, if it's not given, is solve for my rate. And that's all we need for exponential growth and decay.